All right. Hi, everybody. I was seeing everyone introduce themselves in the chat, and that was starting after I'd asked people to introduce themselves, so I thought it was on, but yay, welcome. All right, I'm David Poras. I'm going to welcome you to this webinar, Mathagon 101 at the secondary level. It's great to go back in the chat and see where you're all from. If you haven't introduced yourselves and you want to do that, that would be great, where you are in the world, what your role in education is. I teach 6th and 7th grade math outside of Boston. I am on summer vacation. I'm sure some of you are not yet, and some of you are in parts of the world where your break is probably far way away. So it's great to have folks from all over the world. We are doing the YouTube live stream. I was Zooming for a while this school year, and there are some benefits to the YouTube live stream that caused us to be here, but I made a mistake and we did it. So good perseverance. Yes, thank you. So welcome to the webinar. This webinar tonight is really Mathagon 101, an intro to some of the tools on Mathagon, both Polypad, the courses, the activities. I'm going to switch my screen here and jump in. So let me get the chat over here. I'm going to do this. All right. And so I think what I'm going to be talking about tonight is Polypad, which is our virtual manipulatives, the courses that we have on Mathagon, and some activities as well. I was going to talk for about 40 minutes or so and then open it up to questions. I will still do that. You obviously can bounce anytime that you need to. This is being recorded and we will post it online after, starting from about now, not the first few minutes when I was going there. So let's jump into Polypad. Polypad is our virtual manipulatives. I've used Polypad a lot in my 6th and 7th grade classes over this past year for a number of reasons. One, I've found it's done a great job of allowing students to use concrete tools for as long as they need them and giving them the ability to abstract at the time that their brains are ready. Too often in my classes, we would use tools for a day or two, the physical manipulatives, and then we'd move on. And I'd put them on the shelf and I would tell kids, go use them anytime that you want, but they wouldn't, because if there was some peer pressure, some stigma. I love on Polypad, kids can use virtual manipulatives as they need it until they're ready to abstract. I also think these tools help develop meaning and understanding, and I think these tools help students visualize mathematics. So all sorts of benefits that I want to talk with you tonight. So on Polypad, the tiles here are on the left. There's this panel on the left, and there's a number of categories of tiles. We have geometry, numbers. I'm going to be talking about all of these categories tonight. So these are the tiles, and this white space I'm going to be calling the canvas. So I'm going to start tonight just by exploring these prime factor circles. If you've played the game Prime Climb from Dan Finkel at Math for Love, these might look familiar to you. I can take the 12 and drag it onto the canvas. I also, if I want to get a tile onto a canvas, I can click and it'll show up on the canvas. Well, a little preview of what's about to come there. I could take a number like 150 and type it in and put it on the canvas. I'll zoom in a little bit to make them bigger. And then what is really powerful here is the ability to take these prime factor circles that are on the board game and on other places, but now there's the ability to pull them apart. So I can take this 12 and I can pull out a 2. And I can pull out another 2, and I can see that 12 is 2 times 2 times 3. Same with the 24. I can pull them all apart. I can pull apart a couple of the 150 and put those blues back together to show that 150 is 6 times 25. And I can put the prime factor circles together any way I want. So there's the number 900 and its prime factorization. I've used these a lot with students this year, and I found at the beginning they would talk about them as colors, which was really powerful until they got to the reds, which is all the prime numbers, as you may know. But they would say, oh, 900, it's 2 oranges, 2 greens, and 2 blues, which was a nice introduction to talking about prime factors in a way that I think made sense to them. You may know 2021 is a composite number, and it's the product of two consecutive primes, 43 times 47. The last time that happened was a while ago, 41 times 43. 1763. And then I asked my students if they thought I'm going to be alive the next time it happens. Now they knew that 49 wasn't prime, but I want to show you that has 2 of the same factors. We'll be talking about that in a little bit. Of course, some of my students thought 51 would be, even though we had learned the 3 divisibility rule, And they were like, oh yeah, there's a green in there. Of course, it's divisible by 3. And here's 53, which is the next prime number. So 2491. I'm not going to be here. And so all sorts of amazing things can be done with these prime factor circles. I could spend all night talking about prime factor circles. But what I want to just share one example is a really quick question. Maybe find the GCF of the numbers below. So here's my text box. I just did that at the bottom. I clicked on text box and I started typing. One feature that you're going to notice on Mathagon is when you click on a tile on the canvas, a number of options come up that is specific to that tile. So this is a text box, so I can make it bigger, I could bold it, right? I could change the color of it, all sorts of things. So depending on the tile type, the options at the bottom are going to change. So now let me make 2 questions. I'll say 18 and 30 as question 1, and then I'll do 216 and 252 as question 2. And what I want to show you is just how easy it is to make an interactive workspace for students. So I've made my 2 questions. I'm in a teacher account. I'm going to scroll all the way down to Tools and Utensils, and I'm going to add a question builder blank text box under each of these questions. Now, this feature only shows up in teacher accounts. So I'm going to go to my D in the upper right. I'm in a teacher dashboard. If you first made a Mathagon account and signed up as a student, you can go to account settings and very easily change it to a teacher account. Mathagon is free for everybody, students, teachers, right? So if you switch to a student teacher account, always will be free. So everything I'm showing you tonight is completely free to use for all teachers and students. So I know that this is 6, and in getting ready for tonight, I know that that is 36. Don't have it memorized. I've just done it a few times to get ready. So I'm going to go to library now. These are the tiles. And I'm going to go to library, and I'm going to call this canvas GCF practice. And click save. And I've made classes in my teacher account. I'm not going to show you in the webinar tonight how to make classes and have students join. But I do want to show you that if you click on videos under library, it's going to bring you to a page of teacher resources on Mathagon. And there's a video here on how to make classes and link students. And there's a video on how to share and assign polypads. So that's all there for you to watch if you don't know how to do that. Again, I'm not going to spend time on it tonight, but you can go check it out. So I've saved this canvas. And now I'm going to go to the class tab. Again, this only comes up if you have a teacher account. So I'll click on that. And I'm going to assign this to the webinar class. I've made a sample class for tonight in my teacher account at my school, not my Mathagon account. I have all of my classes here synced up with Google Classroom. But for tonight, I'm going to assign it to the webinar class. I've assigned it. And my daughter is in 2nd grade. She is in this class. And so there's the one that I did as practice. I'm going to get rid of that one, pretending like it's not there. So here's the one that I just assigned to her. Find the GCF of the numbers below. So because she's a student in this class, when she goes to Polypad and clicks on library, anything that I've assigned to this class is going to show up in her assignments. So in a different webinar, I did an addition practice one for a webinar at the elementary level. Here at the secondary level, I've assigned the GCF practice. So I can imagine that a number of my students might know 18 and 30, that the GCF is 6. They could think of the factor pairs in their head and put in 6. Oh, yep, and they got it right. And maybe 216 and 252, maybe they might guess 4. Oh, no, that's not it. Maybe 6. No, that's not it. Maybe 12. No, that's not it. And then I would hope, and this is what I saw happen with my students, a lot of them would get the smaller ones correct. And then after maybe a few thoughts, they would go to the prime factor circles and put the prime factor circles of those numbers on their canvas. And they'd put out 256 and 252, and they'd start working with the prime factor circles until they found the greatest common factor. They both have an orange. Again, I heard my students often talking about the colors. They both have 2 greens. Oh, and it looks like it's 18. Oh, no, it's not, because I missed a 2, right? So there we go, and now it's 36. And I get them both correct, and confetti comes down on the screen. My students really enjoy the confetti. I had students who like would come back to the class assignment at the end of the day to get the confetti, which was just a nice, fun, motivating thing for them to go complete their math. How wonderful was that? And so then under library, she will hit save. And so she has saved this. And now under the teacher account, if I go back to the class tab where I assign this and click a reload, there's her work. And so what I loved as a teacher, I see there's a couple questions in the chat, I'll get to them in a second. What I love as a teacher is being able to see what tools the students needed, which manipulatives helped them be successful on the problem. So I would have a number of students that would use the prime factor circles here. Great feedback for me as a teacher that they found using the prime factor circles of 18 and 30 helpful. And then almost all my students would do them for 216 and 252. In school, I'd have about 25 here, right, of student canvases. You can turn the names on or off. I can see under Emily, it's a mix of orange and green. That means that she got all the questions correct, but some took her multiple attempts to get the question correct. There'd be red if she finished and got a question wrong and was not able to get the correct answer. All right, so a few questions in the chat. Is it compliant with respect to privacy? If you go to Polypad and go all the way to the bottom under the tile tabs or under the library, there's a link all the way at the bottom to the privacy policy. So you can go click and read on the privacy policy. And on our support page, if any school districts needs an agreement signed, we are obviously more than happy to work with school districts to get that in place. You cannot watch the students complete the activity in real time. So what I tell my students is as they're doing it in class, I'll constantly give them a reminder to save. And so anytime a student hits save, I can go to my teacher dashboard on that canvas and then go see their progress. A lot of teachers, myself included, are really excited about the opportunity to see that in real time and have multiple people work on a canvas at once. That feature is not currently available, but it's something that we know would be really, really beneficial to teachers. And so we are working on having that come out at some point down the road. All right, so I'm going to move on from prime factor circles. I was going to talk about square numbers and these number tiles, but I'm going to move on in the interest of time. I'm going to go to a new canvas here. So under library, all the way back at the top, I'm going to go to a new canvas. And before I leave the number section, I just want to show you all these tile types in the number category, right? So number tiles, number bars, prime factor circles. I'm not going to be talking about them a lot tonight. I'd rather focus on tasks that I've used. But if you click on the book that appears when you open each panel, it'll bring you to an instruction page on all of these number tiles. So when I click on that book, it brings me to this entire tutorial on how to use the number bars. There's a quick video of the number bars. There's a space where you can try the number bars on your own. Here's a little video on the prime factor circles. So all of these tile types have a link to instructions that will give you a more in-depth tutorial on how to use those tools. So that can be helpful as you're exploring. I'm going to jump to the geometry section, and I want to show you an example of a canvas. Actually, before I do, I'm going to do a quick jump to the task page. So I showed you the video page, which brings you to our tutorials, videos, and our past webinars. But if you go to the task page, this task page has about 75 puzzles, activities, and lesson plans, all using Polypad. So if I just type in factors, which is what we were just talking about, you can see here's a video that is further examples of how to use the prime factor circles to find common factors with Venn diagrams. If I go back here, here is a series of videos on how to use the prime factor circles to explore finding all the factors of a number in a variety of ways. So those are helpful to explore if there's a topic that you're interested in seeing some ideas about how that could be used on Polypad. Again, that's in the task tab. And when you click on that, you can just scroll through. You can filter by all these types, or you could search here in the box. But I want to show you a way that I explored Pythagorean theorem with my students this past year. So this is a canvas that I made for the webinar tonight. But in school, I had the students make the triangle and the squares themselves with the ruler and the protractor tool. But in the interest of being efficient for the webinar, I have made it in advance, kind of like a cooking show tonight. So what I did with students is, let me back up and talk about all these polygons here. So all of these polygons, when you put them on the canvas, you can spin them, you can cut them into pieces. Any one that you have, you can flip, you can change the color. But this polygon is the custom polygon. And what's great about the custom polygon is you can change the size of it. So the custom polygon, it's now a pentagon. Notice as I move the cursor onto an edge here, and the cursor changes to a plus. If I click on it, it adds a vertex. So I can click here and add as many as I like. If I want to get rid of a vertex, I click on a vertex and it goes away. So I want to show you how I used the custom polygons to explore the Pythagorean theorem. So I certainly did a good, a notice and wonder, and then I had students take the custom polygon and make these squares here. And of course the challenge was, can these two squares fill up the big square, right? Now, when I was doing this with students, I didn't want them to mess up their squares by accident. So notice when I click on a square or a custom polygon, one of the options at the bottom is to fix the vertices. So I can move this now, but now that I have it as a square that I want, I'm going to click fix. And now it's one that I can move and I can rotate, but I can't change the size. So I'm going to fix that. And now I'm just going to attempt to fill it in. And so I'll put the square here, and then I'll take this one and I'll rotate it over. I think this square could rotate a little bit more. All right, there we go. I'll take this one, slide it in here, and then I'm going to use the cut tool. And so I'll take this square and I'll cut it up, and I got this stuff to fill in now. And there's a lot of great videos out there and animations of the Pythagorean theorem of students being able to watch what I'm doing now on the screen, and I know you're watching me do it. But I love that students could do this for themselves, right? That they were actually taking these pieces themselves and really easily taking the shapes and cutting it up and trying to fit them in. I've done it with, Cheez-Its before, is always super fun. I've done it with graph paper where they have the little squares. But this just flows really nicely and allows students on their own to develop in their brains that idea that this is fitting in really nicely. Now, I'm not going to do it perfect here, and I'm going to move on in a minute. I think I'm going to try to finish it off because it feels really satisfying, right, when it fills in. And then certainly in class we talked about why is it not filling in perfectly. I could take this piece and cut it. Students made all different size right triangles to start with, so then they saved it. And then I, as a teacher, went to the projector and I shared them all just like I showed you before with the class, and the class could see all different size right triangles where the two smaller squares filled up the square on the hypotenuse. And then I had them build one that was an obtuse triangle. Again, for the purposes of tonight, I've taken the custom polygon and I've made the triangle and I filled it in. In class, I had students do it, and we can take this and use the cut tool and show that when it's an obtuse triangle, it doesn't even come close to filling it up, right? Not even close. And then in an acute triangle, we do the same idea, and it's going to overflow. I'm not going to take that and cut it up, but we can see that it would overflow. So in the day and a half on this activity, students came away with a really concrete picture of the area of the squares on the legs, perfectly fill up the hypotenuse in a right triangle. We eventually proved it algebraically as well, but that if the two squares are smaller than the square on the hypotenuse, it's an obtuse triangle, and if they overflow, it's an acute triangle. So a really nice way just to build shapes. The cut tool and the custom polygon, really powerful ways to have students explore shapes. The other thing I just want to show you here in the task page, if you search Pythagorean theorem, there's a series videos. Each one's about 4 or 5 minutes where I break down this task in more detail. So if you're interested in seeing how students used the ruler and the protractor to build these squares, you can go watch that video. And then here's how I use the tools for a proof. I have fun having students explore building other shapes on the sides of right triangles. It doesn't always have to be squares. What if we build an equilateral triangle on the sides of right triangles? And then here's a link to our course on Pythagoras' theorem, which you could go explore as well. So that was super fun in the geometry section. I see there's a few questions in the chat. Is Polypad compatible with iPads and other tablets? So it works on any browser. So on an iPad or on any other tablet, you can go to a browser. There is an iPad app and an Android app. Not all of the features on the browser are on the app. Students aren't able to save their work or log in with their account on the iPad app. So if it's something that you're doing, assigning it to them, just doing a browser on the app or on the tablet can work really well. How did you draw the first drawing? Good question. So in this, I'll happily come back to that at the end, just being mindful of time. I'm going to show you that there's a video here that you can go watch for more information. I will show you that there's a pen tool where you can just draw. There is a thicker marker and a highlighter, but there's also a ruler that you can draw straight lines. So I used the ruler tool to make those straight lines and the protractor. All right, I'm going to bounce around to the algebra tools because I'm really excited to share some things with you about the algebra tools. So I'm first going to get that off the screen. I'm going to put a equation on the canvas. So I did a few text boxes. I'm going to do the equation x squared. I click down here to make an exponent plus 8x. Oops, I don't want that to be the exponent. X squared plus 8x plus 7. And I will make that a little bit bigger so you can see it. Again, when I went to the text box, you can choose just a text box or an equation. So I chose an equation, and then there are the ability to make a fraction, an exponent, and a square root. So that's how I got that equation on the screen. And then I'm going to go to Tools and Utensils, and I'm going to put a coordinate system on the canvas. And I want it to count by 3s. So notice when I click on the coordinate system, I can change the x counting by 3s and the y counting by 3s. And then notice when I click on the equation that I've typed, this blue little handle comes up, and I'm clicking and dragging that blue handle until it connects with the canvas and it puts the graph on the canvas. So this is a fairly new feature, came out in the last month or so, where I take this and I can put that graph on the canvas. So I'm going to slide this over a little bit. We don't really need it. And I want to talk about how I can use the algebra tiles to complete the square for this quadratic and show how the graph can help students get feedback in the moment about how they're doing. So I'll go to the algebra tiles. We have an x squared. We have an 8x. I'm going to use the C button on my keyboard to make 8 of them. There's 4. And then I can click and drag and copy all of those. So there's 8x. And then here's my 1 that I need 7 of. 4, 5, 6, 7. So there's x squared plus 8x plus 7. I'll put this grid on the canvas, and then I'm going to make this a square. And so there's a lot of great uses of algebra tiles out there. I'm not going to go into depth about algebra tiles in general tonight. I just want to show you how Polypad can help students create a visual of how to complete the square and how the graph can be helpful as well. So here I've attempted to take the algebra tiles to make a square. I'm going to move it all up here. And I'm going to take this equation and copy it and make it blue. All right, so now if I take this and put it on, it goes right on top of it in blue because I haven't changed anything. So that's expected. And now, obviously, I would do some background with students about what it means to complete the square and why we want to complete the square. But this is not a square, right? I could make this bigger and so it fits. This square needs to be filled in. So I would take a number of 1s. Maybe I'll make these a different color just to have them stand out a little bit. I'll make them this blue, and I know that I need 9 of them to complete the square. So copy, I'm just using the C button on my keyboard to make a bunch of copies, and I've completed the square. And what I find that there are some students don't really have the understanding that what I just did changed the value of this expression, because what I just did was I added 9, right? I had 8x or x squared plus 8x plus 7, I've added 9, but now when I take this and drag it onto the graph, it looks different. It's a different graph, right? Which shows students these expressions are different expressions. So I think that's just a great visual in the moment that when we added these 9, we got something different, right? And that's a problem. So then we would talk about, well, if we added 9 and we want to keep it the same, we have to subtract 9 as well. So then I'd put 9 negative 1s on the canvas. And what is really nice, as you'd expect with the algebra tiles, the 1s and negative 1s make a 0 pair. So now I can show here that by adding the 9 1s and the 9 negative 1s, it really was like adding 9 0 pairs, so that should be an equivalent expression. So I can take this, now I can subtract 9, and now I see that it's the same graph, right? So that shows me this is equivalent. I'll copy it, and we can make this 16. Let's see if I messed it up. Nope, all good, still the same. And now we could show that this, I could take this x and move it up here and show this is an x plus 4, right? And I would take the 4, I'm going to do it actually, and copy these and show that this square that I've made is an x plus 4 by an x plus 4 square. So I'll just copy these and put them down here, and there's our x plus 4 square. So now I could take this and I could go, this is x plus 4, go to my exponent feature, add a squared in here, and now hopefully when I drag this onto the canvas, there we go, right? It's the same thing. So I think on Polypad, that ability to have a graph and the text boxes and the algebra tiles allow students to make really good meaning of both what it means to complete the square, as well as give them the visual feedback through the graph at each step along the way if they were completing the square in an accurate way. So that is exciting, and I wanted to share that. Another just quick task to share is how I use the algebra tiles to explore addition of integers in my class over this past school year. So I just went to the task page, I searched by integers. I was talking at the beginning of the webinar that as a teacher, I would use physical algebra tiles, you know, these positive and negative chips in school all the time. We'd have little baggies of them, we'd combine the chips and flip them over, do it for about a day, day and a half, try to make really good meaning of what the negative ones and the ones mean. I'd put them on the shelf. I would say to kids, anytime you want to use them, go grab the bag, right? You can use them on assessments, you can use them on classwork, you can bring it back home, whatever you want. And even the kids that hadn't abstracted the ideas yet would still never go get the bag, because at least in middle school, I think there was a stigma about if you're using a physical tool to help you make sense of math, that you're not as advanced as a mathematician, despite my attempts to make as safe and as welcoming an environment and encourage the tools. Kids wouldn't use them as much as they needed to. But on a canvas like this, where kids are using the tools in their own space, if it helps them to take the negative 4 and put them here, and it helps them to take the 9, there's 10, so I'll get rid of 1, and they want to actually put them on top of each other and show that that's 5, great. And what I actually found is even when kids were ready to abstract and know that this is negative 4, they also really enjoyed having the 1s and negative 1s make the 0 pair. So there was something about the tools on Polypad that had kids use the manipulatives even longer than they might have needed to, which I think is really great, because I think the more they use the manipulatives, right, those connections of the visual are getting even stronger in their brain. So to have a tool that incentivizes them on their own, out of their own interest, to use the tools, I think is really powerful. So those are the algebra tiles, really quick introduction. I'm going to do some probability tools that I want to show you about. We have all sorts of probability tools. Before I dive in, quick question for you to put in the chat. Here is a coin, that I'm just going to zoom in on. Our coins are heads and stars, right? We have coins that we can flip, and we have spinners. These spinners, you can make them into 2 regions or up to 12. There's a custom spinner where, just like on the custom polygon, if you click on the black circle, it adds a region. You can change the sizes of the region. You can spin all of these at once. But my question for you in the chat is, if I line up 100 coins and I flip all the coins and I find the longest streak of heads and tails, what do you think the longest streak is going to be? The longest run of all heads in a row or all tails in a row. So put in the chat, what do you think the longest streak is going to be? I'll come back to that in a minute. But if we flip 100 coins and we look at all 100 and we find the longest spot where it's all heads or all tails, what do you think that longest number is going to be? So put that in the chat as I share this next canvas with you. So when we began to explore probability this year in 7th grade, one of the tasks that we did, I want to show you. So I'm going to go to the task page. Here's the task page. And I'm going to search for templates. So it obviously came up just at TEMP. There's a number of Polypad templates that we've made that we think would be helpful for teachers to have in the classroom. So I'm going to the Polypad templates, and I'm going to go down to the one that has 50 sets of 3 coins. So this is not in response to the question that I asked you yet. I'm just going to wait for things to come into the chat. So I first asked kids that I asked them to think about how many of these 50 they think would be star, star, star. You can see on the last one I did, there was a lot of star, star, stars. But let me do a click and drag to select all these coins, and I'm going to flip all the coins at once. And it's just a nice visual seeing them all flip at once. I really enjoy that. And so here I could count all the star, star, stars. 1, 2, 3, 4, 5, 6. I think I got 6. And then before getting into any probability discussion or trees, as an assignment, I had students take these 50 coins, flip all of them at once. It's actually, 50 sets of 3 coins. There's 50 sets of 3 coins here. And they counted out of the 50, how many times did star, star, star appear? And they wrote it down. And I had each kid do that about 20 times. And so each student, right, like 20 of these 50 trials, right, 1,000 trials of flipping 3 coins. Now, there's a lot of computer programs that can simulate that for you, and I'm sure I couldn't, but people could write a computer program to say, flip 3 coins 10,000 times and report back how many of them are the same. And the code can share a number. But I think for students to be able to see all the results on the screen and count them and write them down, there's a belief in that, right? Where they might be a little skeptical about the code or the number that comes out. So I had students do it, and then I want to share with you the Google Sheet that I made in school with them. Here are all the results. So each one of these numbers, I know it's small on the screen, is one student's trial of how many out of the 50 sets of 3 coins were star, star, star. So this was 4 out of the 50. That was 7 out of the 50, and so on. And really quickly, I'm going to go back to the top where I did a summary of all the data. We as a class really quickly did 9,750 trials of flipping 3 coins. And again, a computer could do that really nicely, but I think students really believed that number, that we got 1,216 of them that had 3 stars that came out to 0.1247, which, as you probably know, we would expect this to come out 1/8 of the time, which is 0.125. And so first, just to get this huge data set was really powerful, I think, that they believed that number of the experimental probability. And then I took the coins and did a tree, and when we saw that it was 1 out of 8, that was 0.125, they believed the probability tree. And not that I've ever had students really doubt the probability tree that we do, but to have it be backed up not with 20 flips of a coin, but almost 10,000 in a way that was kind of like fun for them to do, I think was a great experience for students. So now back to what I asked you in the chat. I'm going to go back to the template page, and I'm going to go to the canvas that has 100 coins. So here's a canvas with 100 coins. And before I did this with students, I had them, they went to their vertical non-permanent whiteboard space, and they didn't like doing it, but I told them, go to your space and write down 100 stars and heads and tails actually, H's and T's. Try to be as random as you can. And they groaned and moaned, but they eventually did it, and it only took them a minute or so to write down HT, HT, HHT, TT. And then we went around the class and found the longest streak, and I think it was like 5 or 6. And then we went to this canvas. Each student was doing this on their device, and we spun all the coins. And you can see here my longest streak, I think, is right here. Is that 5? I'm probably missing one. Here's a 5. Oh, no, I think I got a 6. So I talk with students how it's just rows going across. So not diagonals, not verticals, that it was like across like this. And then the second row would go like this. So I think here is 1. Oh, no, is this one? 1, 2, 3, 4, 5, 6 is the longest one. But each student was doing it on their own, and we tried to find the longest streak of all the students in the class that were doing it. Here's a streak of 5. I think I'm getting some low streaks. Those of you in the chat had 8, 6, 5, 10, 6, 14, 5, 13, 11. Right, here's a nice streak of 7, I think. And so it turns out that like we as humans are really bad at being random, right? Because when you're doing 100 flips of the coins, you're going to have some streaks. It's hard to predict where those are going to be, right? And is it going to be the stars or the heads? But these streaks do happen. And so that was a good conversation to have with students. A few other tasks that I want to show you, and then we're going to get to the activities and the courses. A new activity that we added to this task page is the Galton board. And I think this Galton board task is a really good example of how multiple tiles and manipulatives on the canvas at once can make for some really high-level mathematics and powerful activities for students. So here's a quick video. I'm just going to go to the Polypad canvas just to give you an idea of how the Galton board works. Here's a little like object that's going to bounce kind of like a Plinko board into the bottom. And so to make some random trials, the task here is you take all these coins and you flip all the coins, and that's going to tell you what happens with this red square. So I'm going to take this red square, and you can see that star is right, so I'm going to go to the right. Heads is left, right, right. So that ended up in D, right? So you can see by this key here, I went right, left, right, right. So I'm going to do it again. And I'll take this and I'll flip it. And I'll take this one and I'll bring it over. And this would be left, right, left, right. And that goes in box C. So it doesn't happen automatically, like students would have to do it, but it's kind of fun to do. I'm kind of enjoying it. And this would go left, left, right, left in B. And so students could go through and do all these trials. You could compile all the results as a class. You can see in this task, which I'm going to go back to, there's all sorts of wonderful extensions and questions. There's canvases where students begin to make a list of all the possibilities. They make a connection to the normal distribution and Pascal's triangle. Further explorations if there's blocks here, what happens if there's blocks. So all sorts of really like rich, deep mathematics on the Galton board that can be done really easily on Polypad. So I think that's a pretty exciting one to share as well. The other one I wanted to share with you that I've done in class is these non-transitive dice. So under tiles, there are coins, dice, and spinners. There are playing cards, which I haven't talked about at all tonight. So you can put a card on the screen, you can flip it, and do all sorts of fun things with the playing cards. But there's also these non-transitive dice. And so these are the classic non-transitive dice where each dice has the same total number of dots. They all have a total of 21 dots. But if I were to ask you questions like, if I spin the red one and you're trying to beat me, which one would you want to spin? If I'm spinning the green one and you want to beat me, which one would you want to spin? And all sorts of great explorations can be done with the non-transitive dice. I'm going to keep going because I want to get to some other topics here and then show you some things about the courses and the activities. And I know we are coming up towards the end here. So let me bounce around to just a few last things on the task page that I think are worth sharing. There's a good interactive version of Curry's paradox where you take these shapes and you fill up the triangle like so. Whoop, I did it. Here's a hint if it's needed, but then it says take the shapes and fill up the triangle differently. And if you haven't seen this before, I'm about to confuse you. It's like, what? What happened? Where'd that extra square come from? Right? It was like this. And it all fit nicely. And then we got that extra square. Where'd that extra square come from? So I'm not going to share the conclusion. You can go through and think about it on your own, but that's a fun one for students to explore as well. We have some puzzles, which are great. One of the puzzles that need to clear that we've gotten a lot of good feedback on is the puzzle of the day. This puzzle of the day is made by a Norwegian puzzle maker. The link to the actual puzzle is here at the bottom, so you can go explore their website and buy an actual physical version of the puzzle. This is shared on Polypad with their permission. The goal of the puzzle of the day is to use all these shapes to cover up everything on the grid except the month and day that it currently is. So what is today? June 23rd, I think. So I could take this and I would leave the June uncovered, and there's the 23rd, and then I'd have to use all these pieces to cover up everything else except June 23rd. I'm not going to be successful right now. Every date has a solution. So this has been a great quick warm-up that I've done with students at the beginning of class, 5 minutes at the end of class, sometimes in the middle of class when we just need a break. It's a really great puzzle that I encourage you to explore and use with students. So before I leave Polypad, I've shared some tasks with you tonight that I've used in school or I thought could be good ones to use with students at the secondary level. Hopefully I've just kind of planted some seeds of ideas of how you could use these tools with students. Some things that I just want to share with you again that I mentioned at the beginning. Next to each tile type is a link to an instruction page on all of these tile types. So if you're trying to do something and it's not quite working in the way that you would expect it to work, go to the instruction page and you can see here there's a whole page on how to use Polypad and the geometry tools. And there's a whole page here on how to use the number tools. So that's a great place to go. If you go to the video page, again, there are tutorial videos and recordings of our past webinars. If you go to free webinars, you can click on this and see our upcoming schedule. You've made it here tonight, so you know that we have the free webinars, but you can go check that out. If you're interested in having a custom professional development session for your team or school, we offer that as well. So you can go click here for more information there. And then, of course, there's the task page. And so you can also just filter the task page by tutorials as well. These are all the ones for the tile types that I was showing you. But there is one that is more of an overview of Polypad. How to copy tiles, how to use the settings, how to go to dark mode, how to save a canvas. So that could be helpful as well. All right, I'm going to go to courses now. I just have a few things I want to share with you about our courses. I've spent a good chunk of time talking about Polypad, but there's a whole other branch of Mathagon that I want to talk about that is also free for all teachers and students, and these are our courses. And so I just want to start by looking at a few examples of how the courses work. So I'm going to go to the Circles and Pi course and go to the introduction. And the first thing that I just want to point out is all of the courses are structured so there's a small bit of text and then there's something for students to do, something for them to watch, a question for them to answer. And if they get that correct, or after some hints they get the correct answer, then additional blocks of text or questions or interactive parts of the course appear. So I'm not going to read this, but there's like a definition of a circle. Any word that is underlined in orange has a definition of it. I click play. it shows me what a circle is. And then 3 measurements, I click on the word radius, it shows me the radius. I click on the word diameter. I'm hovering over the word diameter. And here, before I get any more information, there's a question that I have to answer. So the diameter is the same as the radius? No. Are you sure about that? No. Oh, yeah, not right. It is twice. Yes, well done. This is Archie down here, our virtual tutor. And then it talks about that all circles are similar. And if I'm not sure of that word, I can click on it and get a definition. I drag the circles on top of each other to show that they're all similar. And then more information and interactive pieces of the course are shown to students. If you as a teacher are interested in getting a sense of the course as a whole, at the bottom, you can click this option to show all the steps of the course. And so what I just want to show you here is one feature that comes up in a lot of these courses are these sliders here. So I'm going to click play. This is the way to think about the area of a circle. And as I increase the number of pieces, that looks more and more like a parallelogram. And I can move this back and forth to have a good conversation with students. If I want to do this in class, or if I want students to do this on their own, they could do that as well. And then this is a way to think about the area of the circle that I had not seen before I saw this in the Mathagon course, is you can also take the circle apart into rings. And as you increase the number of rings, it makes a triangle. And just like in the parallelogram, if you explore the base and height in terms of the parts of the circle, you get pi r squared. The same can happen with a triangle. So that's a super fun exploration for students. So that's just a taste of the Circles and Pi course. The other course I wanted to share with you is, let me go back up to courses. I have had so much fun thinking about the wallpapers and symmetry groups. I'm going to reveal all steps of this course. I just want to show you the wallpaper groups in symmetry. So keep going down here. Yep. So what is wonderful here, it shows all the different types of symmetries. So group 1 is just a translation, and then I can try that on the canvas here. So I'm on 1, and if I just draw like making a design, I can see it's just a translation of that design. I don't really know what I'm making here, but I could add some yellow to it, and you can see each shape is just a translation of the shape that I drew. Group 2 is a rotation of order 2 and a translation. So if I wanted to go experience that and I draw something, I can see that each shape is a rotation and a translation of that. So all sorts of fun can be had in the wallpaper groups. I'm going to just kind of jump to a last one and make a fun design. I don't know what number 16 was. We could go check it out. Number 16 was reflections, glide reflections, and translations. So just a really cool interactive part of the course for students. I've done this in school, and students have had a great time making all sorts of beautiful, engaging drawings, much better than mine here. Here's some examples of students' drawings. There are some questions about courses, great questions. A lot of them say under construction, and there's not a timeline that I can share. We are working hard behind the scenes to get additional courses up on the site. We are a pretty small team of content writers and coders behind the scenes. I will tell you, any questions that you have about Mathagon, you can put in the chat tonight, but you can also explore our FAQs, and you can see some of the courses are under constructions. When will they be released? And as it describes here, it can take a long time. So we are working really hard. Don't have a date in mind that I can share about whenever these courses are going to come out, but please stay tuned. If you have a Mathagon account and you are not subscribed to our newsletter, you can do that in settings. You can also follow us on Twitter at mathagon.org. I'm at David Poras on Twitter, so you can do both of those to continue to get updates on Mathagon. But course is coming soon, really, is the best answer that I can give you tonight. There was more in the courses that I was going to share, which I can come back to, but I just want to show you a couple of the activities that we have. There is a timeline of mathematics that goes all the way from the Ashango bone, which is a really fascinating mathematical object. If you're not familiar with it, you can go to the timeline and check it out. All the way, I recently learned about Omar Khayyam as I was learning about Pascal's triangle, as I was exploring Pascal's triangle in the Mathagon course with my students, which I can show you on this link. And I'm going to reveal all steps. There is great information about other parts of the world that had thought about the patterns of this triangle long before Pascal. And so we can see that in the timeline of mathematics as well, all the way up to more current day. We have Karen Uhlenbeck, Artur Avila. We are continually adding and updating to the timeline of mathematics. So if you have any suggestions of either people, mathematicians, or any artifacts that you think would be good to have on the timeline, please get in touch with us via Twitter or on the contact page on Mathagon. So that's the timeline. Some other activities that I wanted to share are the puzzle calendar. Great to hear that people used the timeline at the end of the year. One task that we are working on is a scavenger hunt on the timeline. So teachers could take the scavenger hunt and have students engage with the timeline through some questions on a scavenger hunt. So that will be coming at some point down the road. And I've heard of teachers who have asked students just to go to the timeline of mathematics, pick an artifact or a mathematician, and do some research about it and share it with the class. So that is always exciting to hear that being used. The problems and puzzles. Each December, a new calendar of puzzles comes out, so it goes back all the way from 2017. The number of stars on the puzzles talks about the difficulty level of the puzzle. So here is a 1-star puzzle. Can you place 1 star in every row, column, and region? Stars can't be adjacent even diagonally. It does have a link to a solution, so if you're using this with students and you want to do a screen capture of the puzzle first and share the screen capture with them so they aren't quick just to go see the solution. I've been guilty of that at times when I go to one of these puzzles rather than really digging in. Sometimes I'm a little quick to go click on the solution. So that's a fun one. Here's a 2-star one. How often on average do you have to roll a die to see all 6 sides come up at least once? So this could be a great one just to go explore in Polypad. Have students head to a new canvas and put a dice on the screen and just keep track of how many times they had to roll until they got every number. Of course, you could do this with an actual die in school as well. Each student could do it. You could get a set of data as a class, and then I'm not going to be able to find my tab, so I'll just go back to the puzzle. And then you could use that data set as a introduction to the puzzle. The solution is a pretty involved mathematical solution. I want to show it to you. Go explore it on your own. And then there is a 3-star puzzle, which is, I'll share this one, puzzle 13. How far apart of this are the centers of the 2 circles with radius 1 if all 3 shaded regions have the same area? So this could be a fun puzzle for advanced and older math students to explore as well. So the puzzle calendar is great. We have an almanac of interesting numbers, which is kind of like the timeline of mathematics where there's just facts for all different numbers. So here's the number 13. You may know it's the number of cards of a suit. It's an unlucky number in Western culture, number of different Archimedean solids. You could do a search for a number and see if it's got anything. We got nothing yet for 200, a lot of things in progress. 255 is the largest number that can be represented using an 8-bit unsigned integer. So all sorts of fun things can happen in the Almanac of Interesting Numbers. Right? So we have talked about Polypad. I've shown you all sorts of examples just to kind of pique your interest, hopefully pique your curiosity about ways you could incorporate this with students in your class. We took a quick look at some of the courses. You can assign courses to students, and if students are enrolled in your Mathagon class and they work in a course, you can see their progress in the course. And we took a look at a few of the activities here. So I hope this was a beneficial webinar. I hope you got some ideas of how you can incorporate Mathagon into your classes. I'm going to end the official part of the webinar here, but I will stay on and answer any other questions that you may have.